Okay, we are moving on to our second lesson in our unit of proportions. Your learning target, you can create and solve proportions. That's what you can do today. The first thing you need to know is what the heck is a proportion. A proportion is an equality of two ratios. Or another word for ratios, remember you can write it as a fraction. Anytime you see two fractions equal each other, it's a proportion. Like 1/2 equals 2/4, that's a proportion. Let me think. 3/5 equals 15/25, that's a proportion. If you have an equal sign between two fractions, it represents a proportion. Now, you need to know how to tell if something does create a proportion. The first thing you can do to tell if two fractions make a proportion is multiply one fraction to get the other. And what I mean by that is up here, I times both of them by 2, and so they're the same thing. Or if they simplify, oh, that's my next one, look at that. If they simplify down to the same thing, it's a proportion. And the doozy is this next one. This is the only one I want you to use. This is the 7th grade standard. If their cross product is equal, they are a proportion. That's how you need to verify if two fractions are a proportion. I don't want you to show me these simple ways. This is more elementary. I want you to use cross product. That's the big thing to use. Well, what is cross product? Maybe you already remember from last year, you did have a mini proportion unit last year. A cross product is when you multiply the diagonals. Diagonal, let me just write numbers. So cross, diagonal, product, multiply. That's what that means. Cross, diagonal, product, multiply. And then keep the equal sign in there. For example, I want to know, is this a proportion? That's what I want to know. And I'm not going to use the first two strategies. I'm using the third strategy of cross product. So I'm saying, does 2 times 15 really equal, you're checking to see if it's a solution, if it really equals 3 times 10. Does 30 equal 30? Yes.
No.
Yes, it is a proportion. So if their cross product is equal, then it's a proportion. Next one, again, checking the cross product. Now some of you, here's how easy the first two strategies are. You could simplify this into 1/9, they're equal, they're a proportion. You could use strategy number 1, where you see if you can times both of them by something to get the other fraction. Yes, I can. It's a proportion. But what you really need to utilize for these is cross product. Does 9 times 9 equal 1 times 81? Yes. It doesn't matter which diagonal you use first. You can use any diagonal you choose first. Okay, the next part of our learning target is solving proportions. Now there's a reason why I said cross product is so important. It's the heart of proportions. Proportions are centering and revolving around cross products. The knowledge that if it's in a proportion, then their cross product is equal. It has to be. If their cross product isn't equal, it's not a proportion. So to solve utilizing this, we set their cross product equal to each other and then solve. And I go to the left. You'll see how I do this. Okay, so I'm assuming all of these are proportions. Then I want to solve what is n. So I say, well, I know that 8 times n is equal to whatever 3 times 48 is. I don't know, I'm going to punch it in my calculator. Well, I might go like this for the first one, show you what I'm multiplying, and then I'll actually do it. And then what do I do to find n? I divide. So n equals 144 divided by 8, which is 18. Some of you could, raise your hand if you could have done that mentally. I mean, honestly. 8 times 6 is 48. That's utilizing those first two strategies. 8 times 6, so 3 times 6 is 18. I mean, all of these are ones you can do mentally. All of these, okay? I'm just prepping you up for the harder ones that you can't do mentally. So, I always start with my variable diagonal. 7x equals 42 times 2. 84 dot. 7x equals 84. And what's 84 divided by 7? Is 12. Set their cross product equal to each other again. So now I always start with my variable diagonal. 2 times x is 2x equals 8 times 5. 2x equals 40. X is 20. Okay, now I'm not showing as much work this next time. I have 24x equals 120. So I just do the actual multiplication. This is where I start. I just find each cross product, and then my last step is I divide. X equals 5. Okay, and now this is where the cross product's more important. Can you times 9 by something to get to 12? No. So that's where it's like, what would I do there? Well, you could simplify this and then see if it works. Or just find one main strategy to always use, which is the cross product. Y equals, didn't we just, huh? 6, thank you. Y is 6. Can I times 8 by something to get to 28? No. I could simplify this into 1, 4, and then times them both by 2, but I can use my cross product. What do I want to do? 28y equals 56. Y is 2. Alright, again, to solve with proportions, you need to set their cross product equal to each other. So we do 8 times k is 8k equals 21. Divide 21 by 8. And 2.6 is what k equals. That one is one you cannot solve mentally, which is the majority of proportions are not mentally solvable. Next one, 16t equals 200. Setting their cross product equal. So t equals 12.5. Okay, again, setting cross product equal. 17b equals 3.8 times 51, which is 193.8. And dividing. and you get 11.4. Okay, 7W equals 63, W equals 9. Cross product, equal to each other, solve. 2.5R equals 15 times 8 is 120. R equals 120 divided by 2.5 is 48. Done. Now, this is solving with the proportion given to you. Sometimes, for real life application, you need to create the proportion. How I say this, you create a proportion skeleton, which means you know a proportion looks like two equal fractions. And you say A is to B as A is to B. You have to figure out what are the two things I'm talking about, and then create your proportion. You're always given a first relationship in a word problem, and then you use that to solve a proportion. Okay, so here's our first example. 2 baseballs cost $6. How much for 7? So the two things I'm talking about is money and baseballs. Money is to baseball. So I create my proportion skeleton, and it should be money is to baseball as money is to baseball. So my money is 6 is to baseball 2 as, what should go here, money or baseball? What should go right here, money or baseball? Money. Money goes on top. How much will 7 baseballs? But all I have is 7, so where does the 7 go? Bottom. I'm trying to find money. 2x equals 42, setting the cross product equal to each other. X is 21. Now some of you might be like, I could find my unit price and then just times it by 7. That's totally an acceptable strategy, but proportions is a huge 7th grade standard, so you want to make sure to practice setting those up. 4 CDs cost $54. How much for 3 CDs? So what am I talking about? Money and, yeah, tell me nice and loud, 7th graders. Money and CDs. So I want money is to CDs as money is to CDs. So I create my proportion skeleton. Okay. Money is to CDs. So I have $54 is to 4 CDs as how much for 3 CDs? Do the CDs go on top or bottom? Bottom. So I need to find the top. Cross product, set it equal to each other. Bless you. 54 times 3 is 162. And x equals 40.5. But we're talking about money, so put the 0. $40.50. What I do, a lot of kids mess this up. Here, order does matter where you put the money. Money should always be on top. I always tell my 7th graders, write down what you're talking about. That way, kids don't mess up the proportion. If you write down what you're talking about and reference it, I rarely see mistakes happen. When kids don't write down what they're talking about, I see about 30 to 40% of kids mess up a lot setting the proportions up. 3 pans cost $32. How much can you buy for $100? So what am I talking about? Money and, so I have money and pans. Money is to pants as money is to pants. 3 pans cost $32. So 32 goes on top